Okay, now we have looked at when it bends towards the normal, less dense to denser. We also looked at how it becomes from denser to less dense. The key here is this. So how does scientists determine the density of the object? Or I should say the optical density of the object. What they use is this term called the refractive index. Okay, the refractive index actually tells us how optically dense the material is or the medium is. So example, okay, let me show you some of the refractive, sorry, there's a symbol N. So the refractive index for air is 1.00, for water is 1.33, for glass it's approximately about 1.5, for diamond it is about 2.4. Right? These are the refractive index for air, water, glass, and diamond. Truthfully, the higher the refractive index, the denser it is. So in actual fact, this is the densest among the whole lot here, and this is the least dense. Okay, sorry, least dense. So air is the least dense, diamonds is the densest. So anything traveling to air will actually bend away from the normal because they were always traveling from a denser to less dense if it is traveling towards air. Okay, so the refractive index is a very good indication of how optically dense an object is. Now, scientists, how do they derive these values? So the formula goes like this. N is equals to sine I over sine R. Okay, this is what you will see in your formula booklet. Okay, personally, I do not like it. Okay, I do not like it. And I came out with my own one. It goes like N is equals to sine the angle in air divided by the sine the angle in the medium. Okay, because the refractive index is always sine angle in air over sine angle in medium. It must be traveling from air into the medium. Okay, air into the medium. So this is actually a better representation because sometimes the questions will be set in such a way that glass, air, or normal. If we look at the diagram here, where's the angle of incidence? Here. Where's the angle of refraction? Here. If you use the values here to calculate refractive index, it is wrong. Because refractive index must be light traveling from air to the medium. It must be the light traveling from air to the medium. So if you look at this diagram over here, it is from glass to air. Definitely you cannot use the I and the R to calculate refractive index. You must invert it. So that's why I always prefer this. So what I need to do is, in this case here, if this angle here is maybe, let me erase. Okay, so if let's say maybe the angle here is 30, the angle here maybe is 20. So you can just do a simple calculation, right? Sine 30 divided by sine 20 and you will get the value of n, which is the refractive index. Now, n also has a separate representation. It's also equals to the speed of light in air divided by the speed of light in the medium. Okay, so n is also equals to the speed of light in air divided by speed of light in medium. Most of the time you will only use this. I say again, most of the time. Now sometimes you may need to use this. So just do not forget that the refractive index has two definitions. I should say two ways of calculating it. One is we go by the angle way, which is sine angle in air divided by sine angle in medium. The other way is is also equivalent to the speed of light in air over the speed of light in medium. Always remember, air over medium is a ratio of the air over the medium. It can be angle, it can be speed. Okay, so this is the calculation of refractive index. You can try it out. Okay, you can take your book and go and try. Okay, so this is your refractive index.